All right, 169, I think I've gone over, but some of you missed it. So we'll go over it again. This is from 1.2.1, and we're composing functions. So if we look at, remember the inside part of composing the function is what happens first and then the outside part. And remember your pictures of functions. We have one function machine. You go in, you come out, then another function machine, in, and then finally out. So what this first one is asking is if this is g of x, because we're starting, that's what's in the middle, and this is f of x, if I start with a 2 for g of x, if that's what goes in, if a 2 goes in, what comes out here, and then that output is the input for the f of x, and then what finally comes out of the second machine is f of g of 2, right? F of g of 2, right? So what that looks like is if g of x is 3x minus 1, and I put 2 in, 3 times 2 is 6 minus 1 is 5. So that means my input for f of x is 5, which is 2 times 5 squared, 2 times 25, minus 5 is 45, right? Double check my math. I'm just doing it mentally there. Okay, so this would be 45. Okay, so I'm going to do the same thing here, but here I'm going to start with f of negative 1. So if I do f of negative 1, I don't know why I wrote negative 2. F of negative 1 is equal to 2 times negative 1 squared minus 5, which is that's 2 minus 1, negative 3. Okay, and then that's my input for g of x. So then I have g of negative 3 is equal to 3 times negative 3 minus 1, which is negative 10. Did I do everything correctly there? 2 minus 5 is negative 3? I think so. I think so. All right, you guys, so this next one's kind of cool because what it says is that I still have g of x here, okay, and f of x here, but instead of inputting like I did the first time at 2, my first input is just x. So if my first input is x, this doesn't change at all. And what happens is when we take I keep saying g first. When we take f of g of x, okay, what happens is we literally, since nothing changes in g of x, that whole equation, okay, becomes our input into f of x. So what that looks like is if I write down what my f of x is, it's 2 times x squared, but instead of x, I'm going to leave a blank space because I'm going to put all of g of x. So this entire 3x minus 1, okay? And you can leave it just like that. If a question asks you to simplify, remember the more work you're doing, the more chance you have of making a mistake. Remember that for your AP tests, you guys, for math. But if you were going to simplify it, when you have this binomial being squared, don't make that mistake of just squaring the terms on the inside. When you are squaring a binomial or where you are multiplying two binomials, remember that's you can use an area model, you can use FOIL, but you have to multiply every term by every other term here. So what this would look like is 9x squared minus 3x minus 3x plus 1. What that would look like then is 2 times 9x squared. I'm going to combine those x terms to just be negative 6x plus 1 minus 5. If we keep going, this becomes 18x squared minus, I'm just distributing that 12x plus 2 minus 5. One more step, I can combine these like terms on the end. So it's 18x squared minus 12x minus 3. Okay, so if you wanted to simplify it to be this trinomial here, you could do that, but don't just, I see a lot of this, of 3x squared and then negative 1 squared. That's not going to give you the correct answer. And the last one is just doing that same thing, but we're going to start with the f of x. So that means the f of x is going to go into the middle of the g of x. I'm going to write g of x first, which is 3. Remember, leave a big enough space for an entire function instead of x, minus 1, and then I'm going to put 2x squared minus 5. Now, this is a lot easier to simplify, this g of f of x. I can, since the whole binomial is not being squared, I can just distribute my 3, and I'm going to need to do that before I subtract that 1 on the end, and then you get 6x squared minus 16. Minus 16, yep. All right, you guys, so question number 70, or chapter 1, number 70, is asking us to solve for x, and this is getting us ready for those inverse functions that we were talking about. So what I see is if one side is rational or if one side is a fraction, okay, then I'm going to make this k into a fraction also. And that way, I know I'm going to use the shortcut here, but I'm going to cross multiply, right? And what that means is, or you could just call it multiplying by the denominator, but sometimes it's easier to think about this. So I'm going to do k times x minus 1 equals, right, 1 times 3x plus 2. But that is just going to be 3x plus 2, right? Then I'm going to distribute this k. And you guys, if you don't know how you're going to get x by itself, just keep going. And the more work you do, the more you might be able to see, right? So I know I can distribute this k to make it a little bit simpler, or not simpler, at least different. So k times x minus k equals 3x plus 2. And I want x by itself, so I want to get all of my x's on one side, or anything that has an x on one side and anything that doesn't on the other side. So I'm going to move this k to this side by adding k to both sides. But I'm going to move this 3x to this side by subtracting 3x from both sides. So what I end up with is kx minus 3x equals 2 plus k, or k plus 2. It doesn't matter which way you do it because addition is commutative. And here I know I can get the x by itself. Since both of these terms have an x, I can factor that out. So I'm going to factor out an x, and then I have k. I just simply have k minus 3. You can check yourself. If you distribute this x, you would get x times k is kx, x times negative 3 is negative 3x, equals, I haven't done anything to this side. And now x is by itself. If I divide both sides by k minus 3, I will have isolated x. Okay, so x, if I solve for x, x is equal to 2 plus k over k minus 3. All right, you guys, graph y equals x plus 2 cubed. Let's just make a table. X, y. And let's just go, I don't know, negative 3 to 3. If I enter in a negative 3 value for x, what do I get? So negative 3, that is, let's see, negative 3 plus 2 cubed is equal to negative 3 plus 2 is negative 1, cubed is negative 1, negative 2. All right, that's going to be just 0, right? Negative 2 plus 2 is 0, cubed is 0. Negative 1 is going to be positive 1. 0 is going to be 0 plus 2. 2 cubed is 8. Positive 1 is going to be 1 plus 2 cubed. Should be 27, I think. 3 times 3 times 3. And 2 would be 4 cubed, so 4 times 4 times 4 is 64. And we're getting pretty high. If I did do 3, that would actually be 5 cubed, which would be 125. So whenever you get an equation, you can just make a table and then you can just plot your points. I try to do some positive and some negative points to see what's going on. I also know, if you remember from shifting functions, that this is going to be a parent, x cubed is going to be the parent function, and then this plus 2 on the inside means I'm going to move it to the left 2. So if you know what your parent function looks like, you'd be able to figure this out too. But then you just simply plot it. So 1, 2, 3. -3 was -1. -2 was 0. That's on the axes there. -1 was +1. And +1 was +8. Oops, wrong place. Was +8, and +2 was 64. So this is going to go way up really quickly. So let's just say this is going to be... This looks really funny. I graphed it on Desmos so you can get a better idea, but I didn't. I kind of ran out of space right there. So, I mean, this is the blue line is going to be that graph. So I didn't even go up as far as, whoops. Okay. And then it says, how does it compare to the parent function, just x cubed? And remember, it's kind of like we talked about. We just moved it over this green. If you look at the green line and moved it left 2. Oops. Let me try one more thing. There it goes. So you can see this 0, 0 moved to this -2, 0. So we just shifted all of the x values to the left by 2. Here our x was +1, and here our x is -1. We shifted it to that way. Okay. All right, these are going to be the last questions. I don't have much time to finish it up. I have the free thing that only goes to 15 minutes. So rationalizing the denominator, we need to make the denominator a rational number instead of an irrational number. So 2 over √3. So I don't change the value. I'm going to multiply it by √3 over √3. That means that these just become a +3, and the numerator is 2 √3. Same thing here, but it's going to, I think it's going to simplify at the end, but √2 over √2 is equal to 2 √2 over 2, but look, those 2's cancels out, so actually this is just equal to √2. And here, for this last one over here, we don't need to multiply it by 3 √5. We can just multiply it by √5 over √5, which is then equal to 2 √5 over 15, because the 2 √5's turn into 5, but remember I'm still multiplying it by this 3, so 2 √5 over 15. Do I have enough time? What's the next question that we have there? Let's look. Maybe, maybe not. Probably not now that I'm doing this. Was question 173. Oh, I did do this in class, but I don't, it's going to take longer than a minute. So I'll stop the video here and start the next one.